Okay, today we're looking at the first section of chapter 7, which is on zero and negative exponents. Hopefully by the end of this lesson you can say that I can simplify expressions with zero and negative exponents. So if we take a look at this pattern, an exponent, 2 to the x power. So that's 2 to the 4th power, which means 2 times 2 times 2 times 2, which ends up being a 16. Okay, if I look at 2 to the 3rd power, that would be an 8. Okay, if I look at 2 to the 2nd power, that is 4. If I look at 2 to the 1st power, that is 2. If I look at 2 to the 0 power, that is, well, what is that? Well, let's take a look at our pattern. If I go from 16 to 8, and then 8 to 4, and 4 to 2, how could we explain that? Well, in my mind, we're dividing each time by a 2. So if I am down here then at 2, and if I divide by 2, I'd get a 1. If I take 1 divided by 2 again, I get a 1/2. If I take 2 divided by 2 again, I get a 1/4. So if we try to look at a pattern here, I got 2 to the 4th, I got 2 to the 3rd, I got 2 to the 2nd, 2 to the 1st, 2 to the 0, 2 to the -1, 2 to the -2. And we look at the results we get and try to compare them. I got 16, then 8, then 4, then 2, then a 1, then a 1/2, then a 1/4. So the connections that I'm seeing a connection between these two. Okay, first of all, we could say that those two are reciprocals of each other, as well as these two are reciprocals of one another. So the question becomes, how else could we say that they are related? Yes, they are reciprocals, but how can I deal with the negative exponent? So like for instance, if I had 2 to the -3, how could I deal with that besides looking at the pattern? Well, I know that 2 to the 2nd gives us 4. 2 to the -2 gives us 1/4. Notice the 4 is the same. So really what has happened, 2 to the -2 really is 1 over 2 to the 2nd, and 2 to the 2nd is the 4. So 2 to the -3 is really 1 over 2 to the 3rd, which would be 1 over 8. And if we looked at the pattern of 1/2 to 1/4 to 1/8, our pattern still continues. And if I looked at this idea of reciprocals, the 8 and the 1/8 are still reciprocals. Okay? So if I looked at this next one, let's try and figure this one out. 10 to the 4th power would be 10 times 10 times 10. I think that's 4. So that would be 10,000. Okay, and 10 to the 3rd would be 1,000. 10 to the 2nd is 100. 10 to the 1st is just 10. So the pattern here, we're dividing by 10 each time. So I would get a 1, and then I'd get a 1/10, and then I'd get a 1/100th. Okay, and then the thing is, 1/100th is really 1 over 10 squared. So moral of the story is, how can I deal with this? Well, I can simply deal with it by if I have a negative exponent. So for instance, if I had 4 to the -3, I can rewrite that as 1 over 4 to the 3rd, which is 1 over 64. Okay, so if we took a look at some of these, we just saw on the previous screen that anything to the 0 power right here was yielding us 1. So that's the first thing we got to keep in mind. So when I have 37 to the 0 power, that's really just 1. Okay, and if I have 3 to the 4th power, I could rewrite that as 1 over 3 to the 4th, and then I can use a calculator to calculate what 3 to the 4th is, and we would get 1 over 81. Okay, if I look at this next one, I've got 5 over 5 to the -2. Well, if I've got a negative exponent in the top and I can move it to the bottom, likewise I can move the one from the bottom to the top. So I still have the 5 from the top, and then I'd move this one up and I'd get 5 to the 2nd. So I really have 5 times 25, which is 125. Okay, for this one, to get rid of that 6 to the -1, I would simply move that to the top, and it becomes 6 to the 1st. So really I have 3 times 6, which is 18. Okay, so give you a little time to think through some of these to see if you can come up with an answer here, and then I will explain them. Okay, so for this one, a -2 on the 5, so I'm simply going to do this. I'm going to have a 1 on top now, and I'm going to move that whole thing to the bottom, and it's going to be a +2 for an exponent. So what do I get? I get 1 over a -25. Okay, how do I deal with this one? -1, so to move that, I just simply move it to the bottom, and it'd be 112 to the first, which is really the same thing as just 112. Okay, for this one, we said anything to the 0 power is 1, but if I've got a negative out front, that would make this a -1. For this one, this -2 would go with everything. So here's what I've got. I'm going to have a 7 to the negative, to the second power on the bottom. And I'd still have a negative. Well, you could put that negative on here, or you could put it on top. I'm just going to put it on the bottom with it. So what is 7n times 7n? That's what it means to square 7n. So that would be 7 times 7, which is 49. N times n is n squared. So I got 1 over -49n squared would be your final answer. Okay, if I take a look at a few of these, I've got a 4x to the -3, y to the 0. Well, if we look at it, you got to think of getting rid of negative exponents. So the 4 does not have an exponent with it, so the 4 can stay right where it's at. The x has got to move to the bottom, and it would become x to the third. Y to the 0, that's just 1, so we don't have to worry about it. Okay, if we look at this next one, to simplify this one, the first thing you could look at is the 8 over a 4. That's a 2, so I'm going to put a 2 on the top. My m to the -2, I would rewrite so I'd have m to the +2 on the bottom. N to the -1 on bottom moves to the top, and it becomes a +1. So that would be one way to write your answer there. Okay. These last two we're going to skip over. We'll jump to this one. I'm going to give you some time, and let's see if you can work through some of these, and then we'll talk about them. Okay, so if I've got a 4 to the -2, that would become 4 to the +2 on the bottom. The h to the -4 would move to the bottom as well. It would become h to the +4. And then j to the third would go on the top. Okay, how do you deal with 4 to the second still? Well, 4 to the second is 4 times 4, so that's 16 h to the 4th on the bottom. Okay, if I look at this next one, we're going to skip over that one. Okay, we're going to go down to number 17 here. So if I examine this one, the 10 can stay where it's at. The F stays where it's at. The G's, they've got to move. They've got to go down to the bottom, and it becomes a +5. The H to the 0 is really 1, so we're just going to forget about it. And then H to the -2 on the bottom would move to the top, and it would become a +2. So this would be your simplified expression there. Okay. 18, we're going to let slide. Okay. Now, if I need you to evaluate these, are you able to evaluate these expressions? So all we got to do is plug in the number, but it may be beneficial if you simplify it first. So what do I mean by that? Well, I would rewrite this as 4 over x to the first, because now I don't have a negative exponent. So now what do I got? I really have 4 over a -2 to the first power, which is just 4 over -2, which is a -2. If I rewrote this one, it would be 1 over z to the third. And if I plug in a z as 2, then I'd have 1 over 2 to the third, which would be 1 over an 8. Okay, if I look at this next one, I would have a 2x on top. I would have the y to the second would have to move to the bottom, and a z to the second could stay on top. And then I can just plug my numbers back in, so I'd have a 2 times a -2 times a 2 squared all over a 4 to the second power. So what do you have to do first? You got to do your exponent first. So 2 to the second. This is really 4 then. So I've got a 2 times a negative 2 times a 4. So that's a negative 16 on top. And on bottom, 4 to the second power is 16. So that just simplifies to a negative 1. This next one, I've got z to the 0. That can just cancel out. So I've got 6 times a negative 2 to the third. Well, a negative 2 to the third is a negative 8. So I've got 6 times negative 8, which is a negative 48. Okay, last one we're going to skip for now. So that then is a wrap. And I hope you, if you have questions, that you can bring them to me in class. Have a great day.